Okay, so what we're working on today is just exact value with what I call constraints. And so this is actually just, again, putting together several things that we already know. So recall the signs of each trig function. And remember, that's the all students take calculus. And so all are positive here. Sine is positive here. Tangent is positive here. And cosine is positive here. And we're going to use that later. And then also recall the definitions of the ratios in terms of sides of a right triangle. And so sine of theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is O over A. And then, of course, cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And then cotangent is the reciprocal of tangent. And so remembering all these things is really all we'll need down here. So what I do is I give you a ratio, and then I give you this constraint, right? And so the only difference in these problems and problems that we've actually done before is that instead of just a triangle that is in the first quadrant with everything positive, we could possibly construct this triangle anywhere on the coordinate grid. So first thing we'll realize is that sine, the ratio, is positive, and cosine is positive. And so to figure out what quadrant I'm going to draw a triangle in, all students take calculus. And so sine is positive here, but not cosine. So we're going to mark that one out. Cosine is positive here, but not sine. And of course, neither are positive here. So the only place this is going to work is, in fact, in quadrant 1. So I'm going to draw my reference triangle. Remember, theta prime is always there against the x-axis. And then I'm going to realize that this is O over H. And so this is H, A, O. And so I'm going to label my triangle accordingly. 4 over 5. You can do Pythagorean theorem to figure this out, but I just know that 3, 4, 5 is a Pythagorean triple. So I'm going to save myself some time. And then I'll be able to construct all of the trig functions. So we already know sine. So cosine would be A over H, be 3 over 5. Tangent would be O over A, so that's 4 over 3. And then, of course, we can just construct the rest of these by flipping those over. So at that point, it's pretty straightforward. 5 over 3, and then, of course, cosecant is sine flipped over. So there we go. All right, so it's again the same thing we've been doing, except we have to use the signs of the given trig functions in this constraint to figure out what quadrant to draw the triangle in and figure out what's positive, what's negative, etc. So, all right, let's do another one. So secant is positive, which means cosine is positive, and tangent is negative. And so let's see if we can figure this out. So all students take calculus. In the first quadrant, everything is positive. So that's not happening here because tangent is negative. Tangent is positive in quadrant 3, so that's not happening. So tangent is negative in quadrant 2 and 4, and we need cosine positive, so it's not going to be here. So it will be in quadrant 4. So when I draw my triangle, I draw my reference triangle in quadrant 4. Theta prime always goes here next to the x-axis. Secant is H over A. And so again, this is adjacent, this is hypotenuse, this is opposite. And so I'm going to label that accordingly. So let's see. On this one, I'm going to have to figure it out with the Pythagorean theorem. So this would be a squared plus 5 squared equals 6 squared. Let me do that real quick. So that'd be the square root of 6 squared minus 5 squared. So that'd be the square root of 11 for the opposite side. Square root of 11. So a is equal to root 11. And from here, we have everything we need to construct all of the functions. So sine of theta would just be, O over H. square root of 11 over 6. And then, of course, cosecant would be the reciprocal of that. And then, of course, we would have some rationalizing to do. But we'll just take care of that like this. And it's pretty straightforward. So this is 6 root 11 over 11. And then so on and so forth. You just continue pulling those off. We've done that before, so that's not a huge concern. Again, it's really just the added thing of figuring out where your triangle goes. So cosine of theta is, in this case, negative, and sine is positive. So let's use our all students. All students take calculus. So in quadrant 1, everything's positive and cosine clearly isn't. This one's out because cosine's negative. And so then we have to say, okay, sine is negative down here because tangent's the only thing that's positive. So it's got to be here because that's sine positive and cosine negative. So we're going to draw our triangle over here, and this is theta prime. And so we're going to realize here that this is a over h. Now this negative, does it go with the a or the h? Well, remember that the hypotenuse is never negative. So it's got to be with the a. So let's see, this is a, h, and this is o. And so this has to be negative 2, which makes sense because I'm moving negative in the x direction. And then this is 7. So then we're going to use Pythagorean theorem, a squared plus negative 2 squared equals 7 squared. And we're going to figure out that other side. So this would be the square root of 7 squared minus negative 2 squared. So this is going to be 3 root 5 over here. 3 root 5. And then at this point, it's just a matter of constructing all of the ratios. Okay, let's do one more. And so cosecant is negative, which means sine is negative. Cosine is also negative. So let's figure this out. So all students take calculus. So here everything's positive, and that's not going to work because these two things are negative. Here, sine is positive. Well, that's obviously not going to work because sine is negative. Here, cosine is positive. Not going to work because cosine is negative, and so this is the only option left. So we're going to be in quadrant 3, and let's draw our triangle in the right place, theta prime. So this is hypotenuse, opposite, adjacent. And I know cosecant is a reciprocal of sine, which is O over h, so this is h over o. And again, this negative, we need to figure out where that goes. It's clearly going to go down here because it can't go with the hypotenuse. So this is going to be negative 2. This will be 3. And then we figure out what the O is with the Pythagorean theorem. So this would be a squared plus negative 2 squared equals 3 squared. And whatever that is. I'm not sure. I'm going to have to find it. So 3 squared minus negative 2 squared square root of 3 squared minus negative 2 squared is going to be root 5. So that'll be this over here. And I mean, at this point, again, it's just constructing the 6 functions according to these definitions. All right, so I hope that helps. We're going to work on all of these. All right.